What does congruent mean? It means that two figures are the same, exactly the same. So if we draw two figures in here, and it could be anything, I don't know, I'm just drawing triangles because they're easy, then these two triangles are exactly the same triangle. This side is the same as that side, and we can use a tick mark to show that. This side is the same as that side. I'm now using two tick marks to differentiate between these two, and then I'll use three tick marks here, and that one is going to be the same as that. So all the sides are exactly the same, and all the angles, I probably should have drawn this bigger, but that angle is the same as that angle is the same as that angle, and this angle, I'm using 3, is the same as this angle. Okay, exactly the same shape. So congruent, exactly same. Whereas similar, which we just learned about, means that they're proportional. That they're the same size, same shape, but that one of them is bigger or smaller than the other one. Okay? And now with similar shapes, they have the same angles. Those angles are the same. These angles are the same. And these angles are the same. And this is the key idea. We wrote this down before, but they have the same angles, but their sides are proportional. And that's why we did so much work with proportions. Same angles, sides are proportional. So if this is 2 and this is 6, then we'd say that this is 3 times bigger than that one. And so like if this was 4, then that would have to be 12. So on and so forth. If this was 3, that's got to be 9. This is all 3 times bigger on every side. Every side is proportional. Okay, but we're going to focus on congruency today. So right now, and again, this is the symbol for congruent. We're saying that this shape is congruent to this shape. And they want us to list all of the congruent, corresponding, this is just a fancy word for matching, parts. Now as you can see, they're saying these are the exact same, but they don't look the exact same. That's because this one is kind of flipped and twisted around. So what's probably easiest is to redraw the first one so that they kind of match up. And you kind of visualize, I'm just going to take this and kind of flip it around. But you can use this to kind of help you. Since A is listed first, it goes with H. And so A belongs down there. K belongs where Y is. J is where F is. And G is where R is. And so it just wants us to list the parts. And we really could have done this without the picture. But we'll say that R, since these are congruent, is the same as G. F, and this is angle F, is the same as angle J. Angle H is congruent to angle A, and angle Y is congruent to angle K. Okay, now this is a quadrilateral, meaning it has 4 sides. It also has 4 angles. So 4 angles, and then we need to write the 4 sides. And so we can just say RH belongs to GA. And we could have said HR or RH. That part doesn't matter. But this side matches up with that one. HR matches up with AJ. And I'm talking lines now, so I'm putting a little line above it. And then we're looking at RF matching up with GJ. HY matching up with AK. And FY matching up with JK. Okay. Moving on to example 4. Wants to know, are these shapes congruent? Well, let's check it out. If they're congruent, everything's the exact same. These tick marks mean those sides are the same, those sides are the same, those are the same. These are all right angles. So if the angles are the same, all the sides are the same. So yes. Okay. They are congruent. It wants us to explain they're congruent because everything is the same. Alright, looking now at B, we got this angle is the same as that angle. This angle is the same as that angle. This angle is the same as that angle. Side, 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 side. But triangles have 3 sides, and they're only telling us about 2. And if you're creative right now, you're probably saying, yeah, but they share this side. You know, these 2 triangles are joined by this same side. And so if you broke them apart, well, then we would know that you know, if you came down here and separated the 2 of them, it makes sense that this one be the same as that one because they share it. And that's just called a shared line. Okay, and so yes, these are congruent. Even though we're missing a tick mark, we're congruent because we got 3 angles matching up and 3 sides matching up. Everything is congruent. Okay, and triangles have 6 parts because there's 3 sides. So there's 3 sides, 3 angles. And so looking here, we got triangle cat is congruent to triangle dog. We don't need to draw these. We can just match it up. We know that C is congruent to D because it's first. A is congruent to O. T is congruent to G. Okay, those are our 3 angles, and then we got 3 sides. So I'll do CA, and those are the first 2 letters, so then that's going to be DO. AT matches up with OG. And then, which one did we do? CA, AT, we got CT. CT is first and third, so we'll do DG. 6 parts, 3 angles, 3 sides. Example B, are these congruent? And right now we can see, okay, got 3 sides that match up. And then we just got 2 angles. And so you may say, no, it's not enough information. We only got 2 angles. But we know that all these angles have to add up. In any triangle, all the angles always add up to 180. So 90 plus 30 plus 60. This has got to be 60 so that all 3 of those can add up to 180. And then these 2 angles you might recognize, or you should recognize, they're vertical angles. Or you could have done the same logic over here. Either way, this has to be 60. And so even though they didn't tell us that it was the same, we can figure that out, and we can say, yes, they're the same. We got 3 sides that are the same, and we have 3 angles that are the same. And that's not a very good explanation, but I'm just abbreviating. You get the idea. Now we're getting into the good stuff. Example 6 says, are these congruent? These 2 things. And your first instinct is going to say no. No, they're not. Or at least we don't know. They look congruent, but as we said before, looking like is not good enough. But right now, all that we have is a side, and a side. We don't know anything about the angles. Anything at all. And so, at first glance, it looks as though we don't have enough information. But here's the cool part. If we make a triangle, and I'm just using 3 random objects that are found in my coffee table, I'm using these 3 things to make a triangle. 3 sides. Got a screw, a paper clip, and a thumbtack. If I use those exact same 3 objects, the exact 3 sides, okay, there is no way for me to make a triangle out of these 3 things without it being the same triangle. I mean, I can't put this thumbtack up here at a right angle because these aren't going to connect. The way that triangles work, there's only 3 things, and the pieces have to come together. And so in order to get these pieces together, they got to come together at this specific angle. And you see right there, these are exactly the same triangle. We could get out a protractor and measure and see those angles are exactly the same. So even though they didn't tell us it, if you have 3 sides, That's enough information to know that these triangles have to be the exact same. Get some objects and try it if you don't believe me, but there's no way to any three objects to put them together and then take the same three objects and create a different triangle. It just won't happen. And so what we have here is, this is the first important idea, is this postulate called side, side, side. And that's, if you have three sides, then that is enough information to say, yes, these are congruent. And that's the key idea, is that because triangles are special, and we're getting ready to learn a whole lot of cool stuff about triangles. Triangles are special. Because of that, you can figure out if they're congruent or not with limited information. Okay, with the other shapes, quadrilaterals, pentagons, hexagons, you need everything. You need to know that everything is matching up. But with triangles, we got some shortcuts. Okay, let's look at B. And again, we're only given a couple things. Two sides and an angle. That's it. And so at first glance, you want to say, not enough information. We don't know if they're congruent. We need more info. But if we go back to our objects, if you have two sides, and I'm going to put them together at that angle, if I take the exact same two sides and I put them together, well, this needs to be a little like that. If I put them together at the same angle, and I'm going to try to make it look the same, okay? If I put two sides together at the same angle, there is no way to create another triangle other than this piece fitting, and I didn't do the right angle. But if I put these two sides together at the exact same angle, you know, I can't put a pin here and make a triangle. I can't put this bar there and make a triangle. I can't do it. I have to get something exactly this long because of that angle over there. And so this is the only way to make a triangle, is to put that piece in there. That's it. And so here we have our second postulate, and you probably can guess what it's going to be, is we got side, angle, side. And so these are congruent also because of side, angle, side.